context for when the pattern applies, a general solution for the pattern, and in the book they give this definition of a pattern that says each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use it a million times over without ever doing it the same way twice. And kind of the core of that quote is each pattern describes a problem and it gives the core of the solution to the problem. So you can get patterns in any kind of environment, like if it's architecture, object-oriented software, music, anywhere where there's problems that occur over and over again and we have effective solutions to them, you'll find design patterns. So in the book, in a pattern language, I'm not talking about like strategy and factories and decorators and these object-oriented patterns we heard about. They're talking about things like food stalls, like food stands, where to effectively place food stands in a community for like maximum social benefit. Stair seats, how to like effectively enclose a public space so people have somewhere to sit and they're facing in towards the action. Or something like light on two sides of every room, like how to make aesthetically pleasing rooms, because apparently rooms with two natural light sources are more pleasing than a room with one natural light source. So a pattern is a solution to a commonly occurring problem in an environment, and that environment doesn't have to be software, it can be architecture. So who made software design patterns? So you might, if anyone's studied patterns, come across like the term the Gang of Four patterns, or the term the Gang of Four. So this is the Gang of Four, and in 1994 they released this book called Design Patterns, Elements of Reusable Object-Oriented Software, and those guys are Eric Gamma, Richard Helm, John Vlasides and Ralph Johnson. And what they wanted to do was kind of continue Christopher Alexander's work and make a pattern language for software patterns. So they made this book that catalogues these 24 software patterns, these object-oriented patterns that deal with problems that commonly crop up in object-oriented software. So things like how objects are instantiated, how they're created, how objects are related to one another, and how they behave at runtime. So they're broken down into these three categories, into creational, structural, and behavioral patterns. Each one of them have got a name. And in the book, each pattern has this kind of format where it says the intent of the pattern, like the essence of the problem it's trying to solve, the applicability of the pattern. So does your problem, does it warrant the pattern? Does it apply to your problem? And the structure, which is like normally a UML diagram of the collaborators in that pattern. And some example code, which in the book, it was released in 1994, so it's C++, on a few in Smalltalk. So, but you can still translate them quite easily into modern languages, any other language. And then it provides the consequences of applying that pattern. It's like patterns aren't free. There's pros and cons to applying a design pattern. So another thing was like enabling a pattern language for software designers. So we can talk about these solutions without having to talk about the minutiae of the solution each time. We can just use the name, like we can refactor to decorator or strategy or factory. We can just use the name rather than having to constantly talk about the finer details of the pattern. So where does a pattern emerge from? How does a pattern even come into being? Where did these four authors find the patterns from? So if you take any object-oriented problem, just any arbitrary problem, and then we have some designer working on the problem. So we take some of they know these principles, these good object-oriented principles we use day to day, encapsulation, single responsibility, separation of concerns, so on and so forth. It's not an exhaustive list, but you take these principles that the designer knows, they run it through their design experience, and they come to some initial solution, which is represented by the blue triangle. But maybe it can use a bit of refactoring, maybe it's not as maintainable or as extensible as they'd like it to be, so they refactor and they come towards a new solution. And then maybe they learn more about the problem, so they refactor more, and then they come to another solution, until they reach a solution that they think is, okay, this is an elegant solution to the problem. It's a good, maintainable, extensible OO, object-oriented solution. And for the sake of argument, we'll call this the green triangle solution. And inside of the green triangle, there'll be all these like little details that go towards like making the green triangle solution, but we're going to call it the green triangle. Elsewhere, there'll be other designers working on the same problem, coming to different solutions, represented by the other shapes, but there'll be other designers, other designers working on the problem, and they'll come to something that looks just like the solution of the original designer, the green triangle. maybe inside it the details might be slightly different, but it'll be close enough to be recognized as the green triangle. And this is where a pattern emerges, where multiple different designers have solved a problem effectively in the same way. So what we could do now is just write that up with the same template as a pattern, and then we could incorporate that into our pattern language, and we can talk about the green triangle pattern. Each time we don't need to talk about the finer details that make the pattern. We can communicate this higher level of abstraction by talking about the green triangle. So why should you use patterns? Why should you use patterns? And that's kind of the selling point with patterns, is we're getting the distilled knowledge of designers who have come before us and have found effective solutions, good, what I consider to be good examples of solutions to object-oriented problems. And we don't have to reinvent the wheel every time. If we look through the book, we found like 24 patterns that apply in different situations. We don't have to think of a solution for ourselves each time. We can kind of just apply a pattern. And like we spoke about at the beginning, patterns apply in different environments. It doesn't have to be object-oriented software. It could be functional programming. It could be with people, so in an organization, with apprenticeships, or even like games or cloud architecture. Anywhere there's a recurring problem with solutions, good examples of solutions, you'll find patterns. So when should you apply a pattern? So patterns, there's many ways to apply them. So there's maybe a more effective way to use them, and then there's maybe a kind of like a destructive way to use patterns, a more destructive way to use patterns. So, first we'll look at maybe one of the better ways to use patterns. So a guy called Joshua Kairevsky wrote this book called Refactor into Patterns, and in it he argues that we should start simple, do the simplest thing that works, and we should use patterns as a target for our refactorings. We should refactor to and towards patterns. And we'll have a look at that now. So if you could imagine something like a content management system, a blogging platform, something like that, somewhere where we have the concept of a post. And we're going to go into some JavaScript now. So if there's any JavaScript devs in the room, you'll feel at home. Good, awesome. So anywhere where you have the concept of a post, and let's say we're going to pair on this, and we're going to model it in JavaScript. So it's a lot smaller than I thought it'd be. But if we can still make that out, so we've got this post class, which has got 5 methods on it. So maybe we can, yeah, awesome. So maybe we can update the copy of the post. Maybe we can unpublish it if it's been published. Maybe it goes through some kind of workflow, so maybe it has to be like approved by a moderator or something like that, and then it can be accepted or rejected. So, and then there's also maybe some rules around it. So maybe we can't update the copy once it's waiting for approval. Maybe we can't edit the copy once it's been submitted for approval. Once we've submitted it, we can't change it, something like that. So we're going to have to take different action depending on what state we're in inside of the post in these methods. So one way we could do that as like a first stab, maybe we could try to do something like this. We could have these constants at the top of the class, and we could say, hey, we'll model it by, we'll use 0 for draft, we'll use 1 for awaiting approval, and we'll use 2 and 3 to indicate that we're in the published or unpublished state. And then what we can do is in each of these methods, we'll check those numbers and we'll take the corresponding action for whatever state we're in. So if we're going to update the copy of the post, we could have this if-else structure and say, hey, if I'm in the draft state, do the implementation, do the work for when I'm a draft. If I'm awaiting approval, do the code for awaiting approval, and publish and unpublish the same thing. We're going to check that _draft member and take the appropriate action. But then we're going to have to do the same thing for unpublish. We'll do the if-else check. We'll check the state. And for submit approval, we'll do the same thing. We'll check the state with the same structure. And for approve, and for reject. And what we've got now, we've got a kind of, this is doing something quite simple. It's just doing a console log. But if you can imagine if this was some production code where we had something maybe more sophisticated going on, this would become quite a large class, and the cognitive load is already quite high with something quite trivial. So in this situation, we could say, okay, has anyone solved this problem before? Is there a way we can simplify this? Is there a pattern for that? So if we were pairing on this and we both studied the patterns book, we could say, hey, maybe we could refactor to state. And that might be all we'd need to say to each other, because if we've studied the pattern, we'd already have a mental model of what the final design would look like once we'd applied the pattern. But if we didn't know the pattern, if we didn't know the state pattern, we could thumb through the book and get to the page on state and say, okay, the applicability part of the pattern would say the state pattern applies when operations have large multi-part conditional statements depending on the object state, and usually these are represented by one or more enumerated constants. So we could look at our implementation and say, hey, does this apply to our first pass at trying to model this post? So we've got some constant values at the top of the class, and we've definitely got some multi-part conditionals. So maybe we've got a good candidate to refactor towards the state pattern. And what we'll do with the state pattern is, for each one of those if-else blocks, all the things to do with draft will move out to their own object, the draft state. All the things to do with awaiting approval will move out into their own object. The same for publish, and the same for unpublish. We'll create 4 state objects. And the draft state might look something like this. We'll just do the work for when a post is in its draft state, and we'll put that in its own object, the draft state. So, and it's kind of like as a visual representation of that. We'll take all the work in all the branches where we are going to check for that draft. We'll move out to their own object, draft state. For all the branches where we're going to do some work with awaiting approval, we'll move out to their own object. For publish, we'll move all those guys out to their own object, and then the same thing for unpublished, we'll move them out to their own object. And then with the once we've applied the state pattern, the post class is not going to have these if-else statements in it anymore. It's going to hold on. It's going to have a reference to one of those state objects at any one time. So when we call a method on post, like submit for approval, it's going to forward that call on to the state object that it references. And then the state object is going to do whatever work that it does. So the draft state is going to go, yep, I've done my draft work, and then return the next state object. So in this case, it will transition into its awaiting approval state. And then the next time we call the method on post, that'll just be forwarded on to the state object. So this is kind of what the redesigned code would look like afterwards, where we've not got those constant values at the top anymore. We've not got the 0, 1, 2, 3. We're now importing this draft state. And each method is just going to pass through. It's just going to invoke that associated method on the state. Same again here. No if-elses. It's just going to invoke the same thing on the state. And then this is what the finished draft state might look like. We're just doing the work for what a draft does. And then you notice the returns of each method. They each return a new state object. And now if we do, you don't need to worry about the details on this slide too much, but superficially, if we do the squint test, so there's a developer called Sandy Metz, and she has this thing called the squint test. So if you squint and look at the code, and just look at the color, the outline, and just compare the two, superficially we can see that the implementation on the left, the original code, it's long. We've got the long class code smell. There's more indentation. There's more color. There's basically a higher cognitive overhead than the redesigned code on the right. It's much smaller. There's not a lot going on. It's brain-sized. And that's what we've done. We've taken the original kind of procedural implementation, we've refactored to the state pattern, and we've come out with these 5 objects at the end, where we're going to distribute the behavior over 5 objects rather than having it all in one in the post. And that nudges the marker on this little continuum back to the middle. The code is definitely not super simple to understand, but it's perhaps easier to maintain, easier to extend with new states than the original procedural code. So that's maybe a more valid use of design patterns, taking some original procedural, some problem, letting it express the fact that it's maybe missing some concept, and then refactoring towards a pattern. So the negative side of patterns is where we're pattern happy. And you kind of find this normally when we first start learning patterns, and patterns just creep in for the sake of using patterns. So has anyone done the FizzBuzz kata at all? Anyone use FizzBuzz? Done FizzBuzz? Cool, everyone, nearly. Well, most people. So with FizzBuzz, you've got this very simple problem where you've got this transformation from an integer to string. We're going to loop round 100 times, and then for all numbers that are evenly divisible by 15, we're going to output FizzBuzz. All numbers that are evenly divisible by 5, output buzz, not fizz. And for numbers that are evenly divisible by 3, we output fizz. And then if it doesn't apply to any case, we just change the integer to a string. So that's the essential complexity of this problem. It's a transformation from int to string. There exists a thing on GitHub called Enterprise FizzBuzz. And if you open Enterprise FizzBuzz in IntelliJ, you don't even need to see the details. But believe me when I say there's strategies, visitors, factories, most patterns just slathered on top of this very simple problem. And that's where we get into the discussion of like essential complexity versus accidental complexity. We've taken a problem that is very simple to begin with, and through maybe either inexperience or just a desire to use patterns, or preempting that we need this flexibility that we might not ever need, we've applied patterns and we've kind of come out with this extra layer of accidental complexity on top of it. So with patterns, maybe it's better to do the simplest thing that works first, let the code express the fact that maybe there's a missing abstraction, or that it would be simplified by applying a pattern, and then refactor towards a pattern. So Kent Beck has this thing called the 4 rules of simple design, which I think is like a good barometer for code design in general, where in order of precedence, it's the test pass, the code expresses intent, and there's no duplication, so don't repeat yourself, the drive principle, and the code is small, it has the least number of elements, has the least number of parts to the solution. So if you look at something like Enterprise FizzBuzz, it fails the test. It has just junk, effectively. So with those types of things, we can question our solution and say, is this small? Is it doing extra work that it doesn't need to do? And through that, maybe we do the simplest thing that works and then refactor towards a pattern. It's not always the case, but that's the thing with design. So in summary, what is a pattern? So a pattern is a solution to a commonly occurring problem in an environment, and that environment could be object-oriented software, functional, music, architecture, any environment where there's problems that reoccur and someone's found a good solution to them that's documented. And then where did they come from? So they're born out of skilled designers refactoring their designs. They're coming to these kind of optimal, extensible, maintainable solutions that they've documented. And then why study them? We talked about the fact that we get to leverage the kind of experience of designers who have come before us, and we can stop reinventing the wheel for well understood problems, such as if we're switching on constant values to take action dependent on state. There's the state pattern for that. And then further to that, we can talk about these solutions at a higher level of abstraction. We don't have to talk about the details every time. We can just use the name. So it aids us in our communication. And then when to use them, the last thing we looked at is perhaps it doesn't always apply, maybe at an architectural level, certainly doesn't apply, but if we do the simplest thing that works and then refactor towards a pattern is maybe the safer way to use them rather than go gung-ho and try and anticipate the flexibility we might need by using patterns up front. Cool, so with that, thank you, and I'll take any questions.
I was just wondering, the FizzBuzz Enterprise,
Yes.
was that wasn't like each file was a separate solution using a different pattern, was that one
That was
solution?
FizzBuzz.
Wow.
Yeah.
Cool.
Yeah, so
I'm keen to go and have a look at it.
it's super tongue-in-cheek, but it kind of demonstrates it's not that far-fetched, which is scary. Yeah.
It is written in Java though. So.
Yeah, Java's not that bad.
I bet it tracks.
It's not PHP. Sorry, it's great PHP. Any more? Awesome, thank you.
Let me just, you can hear me now? Yep. Yep, my name's John. I actually work with Tash, as a web developer at Buses Value, but I work on more of the back-end software design part of it rather than the sort of front-end UX part. And I've been a web developer for a number of years now, and it's astonishing how our industry is actually moving so fast. So we're seeming to be getting new versions of JavaScript every single day. We're getting new ways to store data and in bigger formats. We're getting new ways to deliver websites with Docker containers and other forms of deployment. But in the years that I've been doing projects as a web developer, I've been noticing that we're actually facing the same human problems again and again. And so we're finding that rather than the work itself actually being the most stressful part of it, even though it's actually moving so fast, it's actually it's our mutual sort of misunderstandings with other people during those projects that's causing us the most personal stress. So unnecessary conflicts in long-term development projects is the sort of problem I'm going to try and talk about in this talk. Now, the HSE, the Health and Safety Executive, found that 35% of workplace stress was actually caused by interpersonal confrontations. So 2/3 of that from things like bullying and lack of support. Now, this seems quite high, and I looked at the stats, and actually, about 40% of the stress was caused by sort of the workload itself, so the sheer amount of work you have to do each day. But it seems almost crazy how almost the sort of same amount of that is caused by just us sort of having conflicts with the people we work with. And another study, I believe Thor GP, I think it's called, a couple of years ago, said that interpersonal work relationships, so it's a sort of, hang on, here we go. Hey. So a quarter of workplace stress in this study was from interpersonal relationships going wrong. Now, I think this is a problem that's sort of absolutely preventable. Hang on, I got it right. Yeah, so how does this actually relate to sort of long-term development projects? So the projects that run not for a couple of days, like the sort of quick tasks, but things that go on for months and months. And what I found in my experience is that a lot of the suffering that developers undergo are due to problems that are actually really preventable. And I think it comes down a lot of it to understanding the fact that we humans are actually pretty messed up. We're not rational creatures. We're not like the computers that we do work on every day. We're actually pretty irrational. We're jealous, we're territorial, we're hierarchical, we need validation. Even though we're pained to admit it, we're actually kind of like big, anxious babies most of the time, even though we don't want to admit it. And I think sometimes with a lot of the stuff that we do every day, so we're using sort of like, all these like modern frameworks, and we're using this fancy project management software, and we're moving tasks about, that we often actually forget the interpersonal element of development. I mean, we are human beings, and we're working with human beings on a daily basis. And I think that sometimes we forget the fact that we need to be thinking of others' perspectives and try and practice empathy. And I like to call this empathy social intelligence. Now, this is a kind of fancy term for basically not being a dick at work, basically, is if you sort of, rather than sort of try and think of things from your own perspective all the time, particularly in meetings, try and sort of step back and try and just think of things from other people's perspectives as well. So particularly, this prevents unnecessary disputes. It prevents people going away, having bottled up resentments like, oh, I can't believe I didn't get credit for that project, damn it. And that, like, it really affects you negatively in the long term. It sort of burns up inside you. And it ultimately means that you prevent that sort of unnecessary progress halts on long-term development projects. So the main case study I wanted to go through in this talk was actually a company you might know, Pixar. So Pixar are a really successful company that are currently owned by Disney, but they started a long time ago in a way that you might not have expected. So they actually started off as a hardware manufacturing company, And a man named Ed Catmull, who's pictured there, so he was a computer scientist, and he co-founded Pixar out of Lucasfilm with Steve Jobs. So Steve Jobs is usually the one who gets the most limelight in Pixar, but the reason why I like this case study is because as president of Pixar, Ed Catmull didn't necessarily always want the limelight. He was more interested in sort of seeing the process of how the company worked. And it might seem like this is actually quite an odd case study to use because Pixar, they didn't make websites, they didn't do the sort of things that we do. But each film that Pixar made was effectively a long-term technical project. So it actually resembles a lot of the stuff that we do. And one of the main things that Ed Catmull learned while he was leading Pixar, particularly in the production of Toy Story, was that although Toy Story was like an amazing success for the company, it made them the household name that they are now. Soon after they finished producing Toy Story, he went back to his staff and they were talking about creating, okay, let's do the next film, let's create Toy Story 2. But actually, a lot of the production managers, animators and modelers, they said, oh, we're not sure we want to work here anymore, we might go. And so he was really surprised by this. He thought, I thought this is doing really well. Like he was trying to look actively for problems in how meetings went and how communication happened. But when he investigated the problem, he didn't sort of just bash heads together and say, just, try to find a blunt sort of solution to it. He actually found that the production managers were being treated like second-class citizens by the modelers and animators. And in turn, when he was trying to get even further into this, he found that those production managers, because they were under such stress creating this film for the deadline, that they actually heavily restricted the communication between different creative departments. So if you were an animator or a modeler and you wanted to talk to somebody who was doing some aspect of, I don't know, Woody or Buzz's character model, you had to go through your production manager. Now, as anybody who's sort of undergone this in your own work, where this project management anti-pattern, it's actually really frustrating, and it feels like a sort of a school rule where you hate it, but it's sort of there. And when that happens, because it's so difficult to actually communicate with people, rather than try and persist, you think, oh, it's just not worth the bother, so you don't. And it meant that unnecessary bugs got into the final bit of the film, and they had to basically take extra time to solve them, and it just caused a lot of unnecessary stress. And obviously this problem was a really unexpected surprise for Ed Catmull, because he didn't realise that in his own company, the way that they'd been allowed to sort of set up was actually causing problems that he was seeing manifest on a sort of outside level. And one solution he actually came up with was to create what he called a brain trust. Now, a brain trust, in sort of Pixar's example, it wasn't just necessarily a collection of smart people who you ran decisions by. It was actually a different kind of meeting almost, where the brain trust, they were senior leadership of the company, but on a film project, they weren't actually allowed to tell the director what to do. So the director still had sort of final say over his or her film that they were making. And it ended up being a real success, because rather than going into meetings with a sort of defensive posture, so for example, if you're going to go into a meeting with big boss number 1, number 2, number 3, and you know that they're going to dominate the discussion, you sort of go in there thinking, I don't want to look stupid, I don't want to make others look stupid, and it ends up making the meeting as a whole suffer, because you're not being candid, you're not sort of telling the truth as such, but you're not saying things that could be of value for the meeting as a whole. So, what's next? Right, so hopefully this works. So this is actually, so what I'm going to do now is I'm actually going to show you a couple of YouTube clips that sort of show the evolution of Pixar over time, just to see how this sort of human-oriented approach that they took helped them to progress from quite a small company to the huge name that it is known for today. So let's close that. Right. So this is something that actually Ed Catmull created as a school project when he was doing his doctorate, and it's called Han. It's one of the first computer animated shorts. It's from 1972. So not bad graphics considering it was 1972. And and if you sort of, hang on, let me go to the next one. So this is from 10 years later. So this is something that we've probably all seen if you've seen a Pixar film. This is Luxo. It's actually started. Sorry. There we go. So considering that's a gap of 10 years, it's pretty cutting edge as well. And sort of as the final sort of animation slide I want to show you the final product they were able to create in 1995, which you probably might have seen. Sorry about that.
Spaceship! All right, Buzz, get ready. And... Okay, Buzz, when I say go, we're gonna jump in the basket. Buzz! No! This cannot...
Awkward. See, it buffers a bit. Yeah, so that's pretty like, okay. All right. Yeah. Let's close that. So I was trying to, I come back here. No, there we go. There we go. So I've just gone through some of these. Now, I mentioned the brain trust sort of format that Ed Catmull came up with Pixar, and this was sort of hailed as sort of one of the crowning achievements of why Pixar sort of was able to succeed while so many other film companies failed. And I've got one last clip for you, so I kind of lied, and this is actually Ed Catmull explaining how he did this. But I think it's very applicable to us as web developers, especially when we're sort of running meetings or taking part in projects, but how we can make them go a bit more smoothly and try and look sort of deeper for the human problems that are happening behind the scenes. So let me try and pull that one up.
The brain trust is something we happened on accidentally. John is the director, and he had 4 people around him who were very focused and funny and really driven, and they were passionate about the film itself. So they would have intense discussions, but it was never personal. And they basically went through 3 films together. And this was so successful that as other people were coming up, we would add them to this thing. And then Anderson started called the Brain Trust. that the director, the person responsible, was not coming into the room in defensive posture, knowing that this group could screw him over. All right, so it changed the dynamics. But then we had to pay attention to a lot of elements of the dynamics, because in our case, we need a lot of deep candor about what works and what doesn't work. And what we found, and this is true in most places, is there are good reasons why most people hold back and they don't say what they think. They don't want to embarrass themselves. They don't want to embarrass other people. They want to look good in front of.
Oh. Do you mind if I just refresh this page, see if it works? I really want to show you this. No. Okay. Got it. Is that the internet down or something, I think? Try it, sorry?
Try a Wi-Fi connection.
It's always the way.
HTTP?
Sorry, guys. I think you've done it. What, we're on about 2 minutes and 9, I think.
Look good in front of other people. They might want to grandstand. There are all sorts of personal, emotional reasons that get in the way. Frequently, and most of the time, actually, they won't admit that they're there. So our view was that as the managers was not to actually examine the idea at the time. It was to sit back and examine the dynamics of the room. Because if the dynamics are working, they're going to solve the problem. So rather than me get caught up in the problem, I want to say, okay, well, then what they think. And the result is we've got this group which, on the whole, has done completely remarkable things. Every once in a while, it doesn't work. It collapses. And every once in a while, magic happens. But by setting it up and paying attention to it, we've got something where, on the whole, it does, and it's got a remarkable body of work.
Sorry. So I thought you could probably explain it a bit better than I could, having done it himself. Let me just pull this back up. Right. So just to sort of summarize this talk that I'm trying to explain here. So the lessons from Pixar's success story can be summarized into a series of do's and don'ts that I believe we can apply to the world of web development. So first of all, do encourage candor and project meetings for real. So when I say candor, I use the word candor because of honesty, because sometimes you can be a bit brutally honest sometimes, and sometimes it's better to sort of take people's feelings into account as well. So number 2, so do look beyond surface conflicts, practice empathy. So to try and, as Ed was explaining there, try and sort of look beyond the obvious and try and see what's really going on. So just try and talk to people perhaps who are taking part in the groups and just trying to see what's really going on there, because you might find a problem that's going to grow and might mess you up down the road. So do make meetings a safe and enjoyable experience. So we've all been in our weekly meetings where we're just like this and wish we were somewhere else. And sometimes that's because there's one person dominating the meeting and trying to talk over others. And instead try and make it so that everyone's involved and everyone feels like they can contribute their ideas. So don't dismiss quality work relationships. They mean everything. So as I said before at the start of the talk, at the end of the day, we're working with other people, and we need to make sure that we are doing that in a good way. So don't just think that everything has to be rational and objective, because humans are irrational. We're subjective, as I said before. So don't make arbitrary school-like rules. This destroys trust. So the meaning behind this is, it might seem a bit sort of contradictory when I'm talking about like meetings with no interruption rules, but I think a good rule of thumb is for this is that if you're making a work rule, ask yourself, would it make a funny Dilbert comic? And if it is, then probably it's not a good idea. And finally, don't allow power, or be wary about allowing power relationships into meetings, because it spoils candor. So as he was explaining again in that talk there, sometimes if you have big boss 1, 2, and 3, and they're sort of being very openly critical about stuff, sometimes it can make people close up, and you don't want that in meetings. You want meetings to be open and enjoyable. And I think that's it then. Thank you.
Time for questions if anyone has any. Questions? Less of a question, more of just an addition. I was reading a book recently, and a related subject came up, which is to do with performance in teams. And it was a book written by someone in the tech industry, so it relates. And one of the examples was Google did a study of all of their departments a few years ago, and looked at the factors of the success of all of these different teams across different departments. And the number one factor of success was psychological safety. Now, I think that's just an extra point to add on, and I think like your do's and don'ts there that you've come up with is a nice way of implementing practices that increase psychological safety in teams.
I definitely agree with that, and I think out of all the tech companies that there are, I think Google do this better than others. I think. I mean, you can go a bit too far with the safe environment sort of thing, I think sometimes, but I think it's much better to try and make meetings so that people are less in a defensive posture and they think they can actually open themselves up. And I think that as a company, I think Google kind of have to. I think they have. I think I might be wrong, but I think they have more engineers than China or something. They actually are. I don't know if that's actually right or not. But with such a huge workforce, they have to focus on the human relationships between their employees, because if they don't, then it's going to collapse. So I agree with that a lot. Yeah. Yeah, go ahead.
I was wondering, do you think that it's essential to have a role as a facilitator? So I'm conscious that in the Pixar example, your man there was able to essentially be an onlooker outside of the group and realise those qualities of what was going on and take down. Do you think that teams are able to do that themselves, or do you think, for example, in like a Scrum Master or some kind of facilitator is necessary
I think
to help that?
you need to provide a sort of direction for the meeting, otherwise it becomes like unfocused, sort of going off in this direction, that direction, that direction. You need to, I probably should have mentioned that as well, as I was saying. I think I missed that out. You're absolutely right. I think you do need to provide direction, or in the form of like an objective or a problem to solve, and make sure that, like he was saying, you're looking at the process and seeing, like, are they talking well, but are they also talking on topic? Like, are they now slagging off some other trying something else? And it can generate into that if you don't provide a bit of direction, I think. So there's like a balance there, I think. Yeah. Cool.
Thank you very much.
Yeah.
Brilliant. So yeah, we'll take a quick break now. We'll come back about 8:30. So yeah, if you've got any questions or topics for discussion, pop them on the post-it note on the board.
And if you haven't, or if you have, go and vote on the ones that are on the board.
Exactly. You got something to say?
Anyone's leaving now, grab a present.
Exactly.
No one would go before the open discussion.
Heathens.